Hey everyone, and welcome. Today we are diving deep, like really deep, inside our own minds. We're going to uncover this hidden chemical world that's basically running the show, shaping every single thought, feeling, and action you have. Sound cool? Let's get into it.
So let me ask you something. Have you ever stopped to think about what really pulls the strings on your mood, or your memory, or your focus? Like, what's actually going on in there when you suddenly feel super happy, or totally zoned in, or maybe a little bit anxious? Well, spoiler alert, it's not magic, it's chemistry.
And of course, it all starts right here, in the brain. I mean, this thing is the ultimate command center, right? It's running this massive, super fast communication network. And the whole operation? It's all managed by this tiny but incredibly powerful team of chemical messengers.
Okay, so let's zoom in, way in. We're going to go from this big picture of the brain right down to the microscopic level to see how these messages actually get sent. All right, so these little messengers at the heart of everything, they're called neurotransmitters. And you can think of them like the brain's own personal mail carriers. Their entire job, their whole reason for being, is to carry a signal from one brain cell, a neuron, over to the next one.
And this right here, this is where the handoff happens. See that tiny little gap between the neurons? That's called a synapse. And yeah, it looks super small, but trust me, that little gap is some of the most important real estate in your entire body. This is where all the action is.
So how does it work? Well, the whole process is, honestly, it's beautiful and it is unbelievably fast. First, you've got an electrical impulse that zips down to the end of a neuron. That's the trigger. It causes these little bubbles to release the neurotransmitters into that gap, the synapse. They float across and then, click. They bind to receptors on the next neuron just like a key fitting into a lock. And boom, the message is passed on. The crazy part? All of this happens in a fraction of a millisecond. It's mind-bogglingly quick.
Okay, so now that we've got the how down, let's meet the who. Let's get to know some of the key players in this whole chemical drama, because each one has its own unique job, its own personality, you could say.
All right, first up is the famous one, dopamine. I'm sure you've heard of it. People call it the pleasure chemical all the time, right? But honestly, a better way to think about it is as the motivator. It's the stuff that fuels your drive, that gets you to chase after your goals. Dopamine is all about reward and motivation. You know that little rush you get when you finally eat that piece of chocolate you've been craving? Or when you hit a new record at the gym? That's dopamine at work. It's what sharpens your focus and says, hey, that was good, do it again. But, and this is a big but, balance is everything. Too little dopamine is linked to things like Parkinson's disease, and on the flip side, way too much can be involved in conditions like schizophrenia. So it's a delicate balance for sure.
Okay, next on our list is serotonin. Now, if dopamine is the gas pedal pushing you towards a goal, you can think of serotonin as the cruise control. It's the great mood stabilizer. It's what gives us that overall sense of well-being and calm.
Yeah, serotonin has its hands in pretty much everything related to our well-being. It helps regulate our mood, our emotions, our sleep patterns, even how hungry we feel. It's a real jack of all trades. And that's exactly why its balance is so important. When serotonin levels drop too low, that's when you see links to things like depression and anxiety disorders.
So, we've got a motivator and a mood stabilizer. But the brain also needs to manage its overall energy level, right? It can't just be go, go, go all the time. The best way to think about it is like a car. You absolutely need a gas pedal, but you definitely need a good set of brakes too.
And that brings us to these two. On one side, you have GABA. This is the brain's main brake pedal. It's an inhibitory neurotransmitter, which is just a fancy way of saying it tells the brain to chill out. It slows things down, produces a calming effect. If you don't have enough GABA, that's often linked to anxiety or insomnia. Then on the other side, you've got glutamate. This is your gas pedal. It's excitatory. It ramps up activity, gets things firing. It's super important for things like learning and forming new memories, but too much can be a bad thing, leading to problems like seizures or even stroke. So you see, it's this constant push and pull, this balance between GABA and glutamate that keeps everything running smoothly.
And that really gets to the main point here. None of these chemicals are solo artists. They're all part of a huge, complex orchestra. Your mental health, your physical health, it all depends on them working together in this incredibly delicate balancing act.
So what happens when that symphony gets out of tune? Well, the consequences can be pretty serious. Imbalances in these neurotransmitters are tied to all sorts of things: mood disorders like depression, anxiety disorders, and other psychiatric conditions. It's a powerful reminder of just how deeply our biology is connected to our mental state.
Okay, so just to recap our four main players we met today. You've got dopamine, the motivator, serotonin, the mood stabilizer. Then you have GABA, the brakes, and glutamate, the gas pedal. Remember, it's the constant dance between these guys, and many others, that creates the entire chemical landscape inside your head.
And understanding all this isn't just for fun. It's not just some abstract science lesson. This is the real-world basis for so much of modern medicine. When you think about medications like antidepressants or stimulants for ADHD or anti-anxiety drugs, what are they doing? They're designed to work directly on this system, to help tweak the levels of these neurotransmitters and bring things back into balance.
So, that kind of leaves us with a pretty big, fascinating question to chew on, doesn't it? I mean, we experience our lives through our feelings: joy, motivation, love, calm. If all of those experiences are, at their core, guided by this complex chemical cocktail, what does that really say about who we are, about our sense of self? It's just a wild thought, right? That amazing place where our biology and our identity meet.